Dear learners, myself Dr. P. Shaktivel. So we are going to discuss about the applied electronics, the topic of transistors. So in this video, what is a transistor? What is the terminal inside of transistor? Transistor actions, transistor symbols, and transistor connections. So when the third dope element is added to a crystal diode, such a way that two p-n junctions are formed. So that is the resulting device called as a transistor. The transistor is an entirely new type of electronic device. New type of device means is capable of achieving amplification of weak signals in a fashion comparable and often superior to that realized by vacuum tubes. So transistors are far smaller than vacuum tubes, have no filament and hence need no heating power and may be operated in any position. So they are mechanically strong, have practically unlimited life and can do some jobs better than vacuum tubes. So first actually invented in 1948 by J. Bardeen and W.H. Brattain of Bell Telephone Laboratories in USA. So what is transistor? A transistor consists of two p-n junctions formed by sandwiching either p-type or n-type semiconductor between the pair of opposite types. Accordingly, there are two types of transistor, namely NPN transistor, then PNP transistor. So NPN transistor is composed of two N-type of semiconductors separated by a thin section of P-type as shown in the figure. So the P-type PNP transistor is formed with two P sections of separated by the figure 2. So in each type of transistor, actually two major functions. So these are two p-n junction. Therefore, a transistor may be regarded a combination of two diodes connected to back to back. So there are three terminals, one taken from each type of semiconductor. The middle section is a very thin layer. This is the most important factor, the function of transistor. Next, the terminals of transistor. A transistor has three sections of doped semiconductors. The section one side is the emitter, then the section of opposite side is the collector. The middle section is called the base. So, and two forms two junction between the emitter and collector. First one, the emitter. So, the section on one side that supplies charge carriers is called emitter. The emitter always the forward biased with respect to the base, so that it can supply a large number of majority carriers. Majority carrier means the emitter p-type, the PNP transistor is forward biased and supplies the whole charges into its junction with the base. Similarly, the emitter n-type, the of NPN transistor as forward biased supplies the free electrons to its junction with the base. This is the emitter. Next, the collector. The section on the other side of the collects the charges is called the collector. The collector always reverse biased with respect to the base. It function to remove the charges from its junction with the base. The collector p-type of PNP transistor as a reverse biased and receives the whole charges that the flow in the output circuit. Similarly, the collector p-type n-type means the NPN transistor as reverse bias and receives the electrons. The base, the middle section which forms two p-n junction between the emitter and collector is called the base. The base emitter junction is forward biased, only allowing the low resistance for the emitter circuit. The base collector junction is reverse biased and provides a high resistance in the collector circuit. So the transistor has three regions, namely emitter and base and collector. The base is much thinner than the emitter, while collector is wider than the both. Because for the sake of convenience, it is customary to show emitter and collector of to be a equal size. So the emitter is heavily doped so that it can inject the large number of charge carriers, either electrons or holes, into the base. So the base is lightly doped, very thin film. It passes most of the emitter injected the charge carriers to the collector. So the collector is moderately doped. Next, transistor action. So there are two type of working. One is NPN transistor, then PNP transistor. So the emitter base junction of transistor is forward biased, whereas collector base junction is reverse biased. For a moment, we ignore the presence of emitter base junction. The practically no current would flow in the collector circuit because of the reverse bias. So, however, if the emitter bias junction also present, then the forward bias on it causes the emitter current to flow. So, the emitter current almost entirely flows in the collector circuit. Therefore, the current in the collector circuit depends upon the emitter current. So, the emitter current 0, the collector current is nearly 0. So, if the emitter current is 1 milliamps, means the collector current is almost about 1 milliamps. This is precisely what happens in the transistor. So, there are two types, the NPN transistor, then PNP transistor. First, working of NPN transistor. So, in the figure shows the NPN transistor with the forward biased emitter base junction and reverse bias to the collector base junction. So, the forward bias causes the electrons in the N-type emitter to flow towards the base. So, this constitutes the emitter current IE, as these electrons flow through the P-type base. So, they tend to the combine with holes. As the base lightly doped means the very thin, therefore only few electrons means less than 5% combine with the holes to constitute the base current. The remainder, more than 95%, cross over into the collector region to constitute the collector current. In this way, almost entire emitter current flows to the collector circuit. It is clear that emitter current is sum of the collector current. Means emitter current equal to the sum of the current, sum of the collector and base currents IB plus IC. So next, the working of PNP transistor. So in the figure, the basic connection of PNP transistor, the forward bias causes the holes in the P-type emitter to flow towards the base. So this PNP transistor constitutes the emitter current, as these holes cross into the N-type base. So they tend to combine with the electrons. As the base lightly doped may be very thin, therefore only few holes, maybe less than 5%, combine with the electrons. So the remainder, more than 95%, cross into the collector region. So the collector current, almost the emitter current flows in the collector circuit. It may be noted very conduction with the PNP transistor by holes. So the external connecting wires, the current still by the electrons. So the importance of transistor action. So the input circuit means emitter based junction has low resistance because of forward biased, whereas output current the collector based junction has high resistance due to reverse bias. Next, transistor symbols. So the transistors have been shown the electric diametric diagram form you have to see. So, however, for the sake of convenience, the transistors are represented by the schematic diagrams. The symbols used for PNP and NPN transistors. So, note that the emitter is shown by the arrow which indicates the direction of conventional current flow with forward bias. For NPN connection, it is clear that the conventional current flows out of the emitter flows out the emitter as indicated the outgoing arrow. So similarly, PNP connections, the conventional current flows into the emitter indicated by invert arrow. Next, transistor connections. So there are three LEDs in transistor: emitter, base, and collector terminals. However, when a transistor is to be connected in a circuit, we require four terminals: two for the input, two for the output. So the difficulty is overcome by making the terminal of transistor common to both input and output terminals. The input is fed between the common terminal and one of the other two terminals. So the output obtained between the common terminal and the remaining terminal. Accordingly, the transistor can be connected in a circuit. The first one, common base connections, the common emitter connections. Each circuit has specific advantages and disadvantages. It may be noted that regardless the circuit connections, the emitter is always biased in the forward direction, while the collector always the reverse bias. First, common base connections. So in this diagram, the input is applied between the emitter and base. The output is taken from the collector and the base. So here the base of transistor is common to both input and output circuits. hence the name of common base connections. Next common emitter connections. So in this diagram, the input is applied between base and emitter, and output is taken from the collector and emitter. So here emitter of the transistor is common to the both input and output circuits, hence the name of common emitter connections. So summary. The summary of this video: a transistor consists of two p-n junctions. So p-n junction is the sandwich of p type of material, then n type of material. Next one, then collector, the base, and emitter, these three type devices of the transistor. Next one, the two types, the NPN transistor, PNP transistor. Next one, then common connections, common base connections, and common emitter. So thank you.